The heat transfer for energy savings team created a heat recovery system at Herd and Horns located on 12th Avenue to reduce the restaurant's energy consumption and operating costs. Hot air was exhausted from a condenser into the open attic space above the dining area. This increased the ambient temperature around the condenser and in the attic, increasing the demand for air conditioning. The opposite problem was occurring in the men's restroom at the game room side of the restaurant. Heat was lost through the restroom floor and brick wall to the outside, causing the room to maintain an uncomfortably low temperature and require heating. To warm the restroom, energy from the hot air exhausted from the condenser is transferred to water flowing through a cross-flow heat exchanger. A fan located above the restroom moves air through a second heat exchanger. Energy is transferred from the warmed water to the air, and then the air is diffused into the restroom to increase its temperature. This cools the water, and the cycle continues. When the restroom is at its desired temperature, the water is redirected to an indirect water heater where the warm water heats the main water supply used for washing dishes and other warm water applications. Water is circulated through the system with a pump. A 4-branch manifold and 2 zone valves allow the system to switch between the 2 different water lines. The additional branches on the manifold provide the opportunity to expand the system and transfer heat from the other condensers in the attic. A zone controller monitors the zone temperatures with a thermostat. It controls the zone valves to direct the system water to where heat is needed. The restroom circulation fan is shut off when water flows to the indirect water heater to reduce the energy consumption of the system. Subassemblies were designed to reduce the project installation time at Herd and Horns. Each subassembly was required to pass through a 2-foot square opening in the ceiling. With the design completed, it was time to get to work. After completing the installation, a soapy water test was used to find leaks in the system. All leaks were sealed and distilled water was pumped into the system to reduce heat exchanger fouling. Air was bled from the system. A water temperature increase of 12 degrees Fahrenheit was observed between the inlet and outlet of the heat exchanger mounted on the condenser for the water line to warm the bathroom. No more freezing on the toilet. The design team would like to thank Dr. Adam Gladen and Dr. Jessica Vold for mentoring the project and Russell Schell from RJ Energy Solutions for sponsoring the project.